Okay, guys,
We'll get this started this morning. I'm talking a little quietly. I have sick people all over the house right now. That stomach flu, if you guys have had it, has not been a very fun one to us. So we'll just kind of work it out. You got a little Leonard Skinner in the background. Uh, for those that are not musically inclined, they're a very old band, but maybe you guys will be musically enlightened. So today we got a couple different things we got going on, and I'm talking quietly and not depressed, as Mr. Riggy said I sounded in one of the videos. So Alex, I'm happy as can be. Hey, graphing equations. I want you guys to kind of realize that when we graph equations, especially ones using parent graphs, these are some possibilities that you can do. Don't remember, they're not perfect steps. You don't have to follow one step after another step after another step after another step after another step. So these are just ways you can solve them. First, we find and plot the vertex, the center, or the starting point like we did with trig. You solve for the x-intercepts using algebra. You can possibly find the y-intercept if you need it. Don't always have to have it. And then plot all points in sketch. And then sometimes if it's a word problem, you got to interpret the problem if needed. So like, what's the maximum height the rocket flew or whatever. But those are 5 possible steps you can use to graph in the equations. Now, we have some, let me move this lamp back a little bit. We have some tools that you guys have been taught. Factor to find the x-intercepts. Don't forget we set equal to 0 because that would be our y, and we make our y's 0. You also have the quadratic formula to find the x-intercept. That's an old one, and it's negative b plus or minus the square root of b squared minus 4ac all over 2a. You can look that one up. I'm not going to write it down, but if you like the quadratic formula, you either have to memorize it or you got to look it up. I don't use it very often. You have find the vertex, which is your maximum or your minimum, by finding h and k using what we did yesterday, or you can find the vertex by finding x to the vertex, and then you do that by making sure it's in standard form and do negative b over 2a, and then you take that answer and plug it into f of x. So these are all different ways that you guys can solve some of these problems. I don't care which way you choose. Just make sure we get good at something and that you're comfortable with it. So we talked about graphing yesterday. We're going to talk about a little bit more graphing today because that's kind of where we're headed. So we're going to be looking at this piece here. So I'm going to kind of follow those simple steps, and we're going to kind of hone in on the algebra piece right here. So we're going to look at this piece here, and we know it's an absolute value because of the absolute value bars. So I know already that this is going to be some sort. If I was to kind of think of what this thing looks like, I know the graph is going to be a V shape somewhere. That means I have a vertex right there. So if I have a vertex right there, I want to find it as quickly as possible. So I look at this and I say, okay, here's my A, here's my B, here's my H, and here's my K. Well, I know that the vertex, this is negative H. I know the vertex is H and K. So my vertex, or in this case, because it's a positive, it's going to be my minimum. So I know my graph doesn't go any lower than this. My minimum is going to be -4 and -2. So that piece right there is my x and y. Now I can plot that. So my vertex is this. So my -4, 1, 2, 3, 4, 1, 2. So that's -4 and -2. So quickly I've graphed that. Now, this next part is I'm going to find my x-intercepts. I'm not necessarily going to go automatically to here and find one to the left and one to the right. I would rather do something that's going to give me 2 points and I'm done. So I'm going to find my x-intercepts, and that's where algebra comes into. If I'm looking for my x-intercepts, it means y is going to equal 0. Well, if you guys remember, this is the same as y. So I'm going to take this, make it y, and set it equal. So that's where we get the whole idea of setting it equal to y. So we're going to get 3, oops, broke my pencil, so I don't use those. 3, 3x, oh, broke it again. This is why I don't use these pencils. Oh, oh, oh. Plus 4 minus 2 equals 0. So this whole thing equals 0. I'm going to rearrange this piece here. Oops, I did something wrong. I just noticed it right now. So I forgot to divide by b. This is 4 over 3. And so let's change this here real quick. So 4 over 3 is negative 1 1/3, so I'm going to make my 1 right there and my 2 right there. There we go. Negative 4/3. Okay, so that should be b over h. Sorry guys, early in the morning. All right, so when you work with absolute values, I want you guys to make sure that this absolute value sign is by itself on one side. So I'm going to move the 2 over, and then I'm going to divide by 3. So we're going to get 3x plus 4 absolute value equals 2/3. I'm not going to take time to show that. If you can't solve 1 or 2 step equations like that, just come see me. But we need to start saving time in class on and get the skills that we have to have. So this is the idea. If I excuse me, I move the 2 over, it becomes a positive, and I know I got to divide, so I divide by 3. Now with absolute value pieces, I have 2 equations. Because absolute value, this means the distance from the center. So if we take this idea, this is my center, right? I need to find a point that's, so if you guys can see that, this is my center, or my line of symmetry. You probably can't see that line of symmetry. That's my line of symmetry. Meaning that my 2 points are exactly the same. One's 2/3 to the left and one is 2/3 to the right. How do I know 2/3? Because absolute value means distance from the center. I know that it's 2/3 away. So that tells me that I have an answer that is 2/3 to the left. Oops, 2/3. And then I also have an answer that is 2/3 to the right. So we have a negative 2/3 and a positive 2/3. So this accounts for my answer to the left, and this one accounts for my answer that is to the right. So then I solve these two. Yes, they're fractions, but we're going to start working with fractions a lot more. And this is going to be 3 times 4 is 12, negative 12 minus 14. 9 is 12 is negative 14, negative 14 thirds, 3x. And then divide by 3, so x equals negative 14 ninths. Then we have this one here, so I've got x equals negative 14 ninths and my y value. So this is negative 14 ninths and y value is 0. So 1 x-intercept is negative 14 ninths and 0. And I know I have another one to the right because I have one to the left. I have one to the left and I have one to the right, which is going to be this one. So we have 3x equals 2/3 minus 4. 3x equals negative 10 over 3, which is 3 times 4, which is 12. 2 minus 12 is negative 10. X equals negative 10 ninths. So we have negative 10 ninths and 0. Oops. And 0. So now we have negative 10 ninths and 0. All right, so I've got all three pieces. Negative 10 ninths is right about here. It's 1 1/9. And that's going to be 1 and it's going to be right about there. So then I just draw my graph. Oops. Ha! There we go. Negative 14. This piece here I'll have to get used to a little bit. Let's go this way. That's as far as I can go, guys. So we can solve algebraically and we can find the pieces that we need. We could plug in x equals 0 to find the y-intercept, which is going to be way up here, but there's no need for that one. So again, all I did was follow these, plotted the vertex, solve for the x-intercept, sketch the points, and I didn't have to interpret the problem because it wasn't a word problem. So just kind of following these steps. So let's tackle this one here. Let's tackle here. Let's look at this here. So we have a quadratic. So let's look at the graph real quick, just so we can kind of get an idea. We have the idea here that it's x squared. So x squared tells us that f of x is going to look like a U shape. It's not negative, so we're okay. So we're going to have some sort of a U shape, so I can find the vertex and I can find the x-intercepts. So for me personally, when I see something like this and it's not clear what the vertex is, I always go to the x-intercepts first. So I'm going to take this, x squared minus 3 equals negative 2x. And I'm going to rearrange it. So I get x squared plus 2x minus 3 equals 0. Now I'm going to factor this piece because now I can find what x is because it said, it said equal to 0. So what multiplies together to make negative 3 but adds to make 2? X plus 3, x minus 1. 3 minus 1 is 2. So we're good. And then 3 times negative 1 is negative 3 equals 0. So we use our zero product rule and we set these equal to 0, x equals negative 3, and x equals 1. So we now have an x-intercept because y, remember that's y. We know we have negative 3 and 0, and we have 1 and 0. So I can go back up here, and I can go 1, 2, 3, and I can go 1. So those are my two x-intercepts. So I have x-intercepts of negative 3 and 0 and 1 and 0. Okay, so I've got my x-intercept. So now we know it's something. We know it looks like this. It's going to go this way. We just got to figure out how far on the bottom it is. So we need our vertex or our minimum. So I'll go up here to the numbers part, and I'm going to say, okay, all I need to know is the center. Well, I know the center's at 1. So if the center's at 1, and I plug it in, I can put 1 in right here. And then I can put 1 into this equation, because remember, all we need to do is substitute this piece in. So I'm going to get 1 squared plus 2 times 1 minus 3. And that's going to give me 1. This is where I messed up yesterday. How's that going to work out? What happened? Oh, it's -1. Sorry, this is at -1. That's -1. -1. That's -1. So that's going to be, it's going to be +1, -3. It's going to be at -5. No, +1, -4. So let's see, -1 squared is 1, -2, -3. Yeah, it's -4. So I'm going to go down to -4, draw my graph, and I could find my y-intercept if I needed to, but since we just want to graph it and sketch it, we're good. So multiple issues here. Use our factoring that we've practiced already. Zero product property. This is probably all a Math 2 skill. We're substituting in our center. If you don't know the center, you can use this. X of the vertex is equal to -b over 2a. Well, if we go here, my b is negative. My b is 2, and my a is 1. So if we look at that and we plug it in, 2 over 1, my x is equal to -1, which is what I used anyways to plug in. So you can visually look at it. That's why I like using the x-intercepts, or you can find it using x over -b over 2a, which is something that I talked to you guys about at the beginning, right here. You can use that also, and then you substitute it in for f of x. All right, so now my minimum is -1 and -4, x and y. So find your x-intercepts, plot them, find your vertex, plot it, sketch it. If this is a word problem, I would be interpreting the graph. All right, so we got one more, and then you guys will be on your way. A lot of info today. So now, again, we're at a point here where it looks a little different because it's in a different form, but let's just kind of take some of this information. What's this graph going to look like? This is my y, this is my x. Well, this piece here has an x squared. So again, this is going to be some sort of a parabola. So I need to find a vertex, which the way it points is my minimum. And then I need to find my x-intercepts. Need to find my x-intercepts. Okay. So, oops. So I've got a little bit to work with here. I've got this piece here, which is a little different form. I need my vertex and my x-intercepts. Well, this is h and k. So right off the bat, I'm going to say, all right, my vertex, or my minimum, is 4 and 1. So this piece right here gives me 1, 2, 3, 4. 1, and I know it points up. So from there, I'm looking at this going, okay, does this thing even cross the x-intercept, the x-axis? No. So if I'm looking at this and I go, okay, why am I going to solve? There are no x-intercepts. Okay? Now, if we want to prove it, we look at this and say, okay, x minus 4 squared plus 1 equals 0. X minus 4 squared equals -1. Now to solve this, I have to take the square root of both sides. And I get x minus 4 equals plus or minus 1i. Because it's imaginary. It's an imaginary root, which is -1. That's when you take the square root of -1. So this answer is x equals 4 plus or minus 1i. That right there is not a real solution. So that's why there's no x-intercepts, because we have imaginary roots. So remember, this is imaginary. That's imaginary. So my x-intercepts are imaginary. And those would be x equals 4 plus or minus 1 root I. Okay. If I wanted to, now I don't really have another point, so I would go up to numbers here, set my chart, and I want to find my y-intercept. Well, my y-intercept is when x equals 0. So then I know that it's 0 minus 4 squared plus 1. Well, that's going to be -4 squared, which is 16, plus 1, which is equal to 17. So I know at 0, it's 17. So it's going to be 1, 2, 3, 4, 5, 6, 7. It's going to be way up here at 0 and 17. So now I can sketch the symmetry, and then I have my parabola. Don't forget, as you solve for these, we're going to move over. Here is your number 1 spot, square root both sides. Sometimes you'll get an imaginary number, sometimes you'll get an actual answer. So we have 3 different types of problems today. And you're going to utilize these types of steps, whatever order you want. You're going to find your vertex and your x-intercepts. Vertex, x-intercepts by factoring. Vertex, x-intercepts by setting equals to 0 and using SADMEP, or your PEMDAS backwards, remember. We're going to add, we're going to subtract first, we're going to take the square root of both sides. Don't forget, if you take the square root of a negative number, you're going to get an imaginary number, which is going to give you an I, and then we have our answer there. So that's kind of it for today. Lots of information today. Half of it's review, half of it may be new. Most of it should be review, but there you guys go.